So let us try out some more example based on this concept. So let's have more examples. Okay, we'll go with another example. Show that the function f of z is equal to x square y x plus iy or x raised to 4 plus y square if that is not equal to 0, and this is equal to 0 if z is equal to 0. Satisfied satisfies CR equations, but not analytic at that is equal to 0. Okay, so we have to show that these equations, this function satisfies CR equation, but it is not going to be analytic. Okay, so let's have here. We have the example. Show that f of z is equal to x square y x plus iy on x raised to 4 plus y square if that is not equal to 0 and is equal to 0 if z is equal to 0. Satisfy satisfies CR equations, but not analytic at that is equal to 0. Okay, so this is what we have to. Okay, so we go with the solution. Right, f of z equal to x square y x plus iy on x raised to 4 plus y square or z not equal to 0 and this is 0 or z is equal to 0. That is, we can say f of z is equal to 0 being the function of complex variable. Okay, so we have to follow first we have to show that this satisfies CR equation, and then we have to show that it is not analytic. Okay, to find the CR equation, first what we have to do is we have to separate the real and imaginary part of this function. So we have f of z is equal to x square y x plus iy on x raised to 4 plus y square. So what we'll get here, this is x cube y plus I x square y square on x raised to 4 plus y square. Okay, So what we get here, we can write this as f of z is equal to x cube y upon x raised to 4 y square plus I x square y square on x raised to 4 y square. And hence we write f of z is equal to u plus iv, where u is equal to x cube y on x raised to 4 plus y square, and v is equal to x square y square on x raised to 4 y square. So we got the real and imaginary part of this function. And now we have to find the CR equations, whether they are satisfied or not. So to calculate the CR equations, we first have to calculate the first order partial derivatives for this function. Okay, so we consider w by x. So this is equal to what we get here. So we know the derivative of u upon v. So it is v derivative of u minus u derivative of v on v square. And hence we consider here this is going to be u, this is going to be v. So we have x raised to 4 y square p x square y minus x cube y, and you will be having 4x cube. Here this term divided by x raised to 4 y square bracket square. Now we calculate w by y. So with respect to y, we have to calculate x raised to 4 y square, and this term will be x cube minus x cube y, and this is 2y upon, you will have x raised to 4 plus y square bracket square. Now here we have calculated the derivative of u with respect to x and y. Let us calculate the derivative of v with respect to x and y. So we have w by x is equal to x raised to 4 y square into 2x y square minus x square y square into 4x cube upon x raised to 4 y square bracket square. Okay, so that's what the derivative of v with respect to x we have. Now the derivative with respect to y. So w by y is equal to x raised to 4 y square 2 x square y minus x square y square, and you'll be having 2y on x raised to 4 plus y square bracket square. So these are the derivatives, first order partial derivatives we have. But we have to consider where we want to find out the analyticity of this function at z is equal to 0. Okay. So we want to test what happens at 0. So what will happen at z is equal to 0? That is, what is the case you will be having? X will be 0. X is equal to 0 and y is equal to 0. And hence we have what will be having w by x is equal to 0, w by y is equal to 0, w by x is equal to 0, and w by y is equal to 0. So we have w by x is equal to 0, w by y is equal to 0. So w by y is equal to 0. So all these first order derivatives are going to be 0. And hence what we can say is, so we get what we are able to get, w by x is equal to w by y, and w by y is equal to v by w by y is equal to minus w by wx. So that is what you can say is CR equations are satisfied. Okay, CR equations are satisfied, but we cannot guarantee that this function is going to be analytic, as we cannot test the continuity of this functions, and hence we have to be careful. So, though the necessary condition is satisfied, but sufficient condition is not yet satisfied, and hence we cannot guarantee that this function is an analytic function. So, to guarantee, we need to find whether the derivative exists or not. Okay, so now we have, okay, we'll consider the derivative. So what is the derivative we have? Limit z tends to 0 f of z minus f of 0 upon z minus 0. So limit z tends to 0 x square y x plus iy on x raised to 4 plus y square minus 0. Here we have x plus iy minus 0. Since what we know is z is equal to x plus iy. So I have replaced this z in terms of x and y because my function is in terms of x and y. And now what will be having? Limit z tends to 0. So this term will get cancelled with this term, and hence I'll be having x square y on x raised to 4 y square. Okay, so what we know is since z tends to 0, this implies x tends to 0 and y tends to 0. So we are able to write this limit as this will be limit x tends to 0, y tends to 0, x square y, x raised to 4 y square. Now this has turned out to be the simultaneous limit. So limit x tends to 0, y tends to 0. So I have here x square and y. And this term is x square plus y square. Okay, so when you will write this way, then you are able to guess what the relation which is going to help you. What is the relation that you need to know? Okay, so here what we have in the numerator, we have x square and y, and the denominator we have the powers of x square and the powers of y. So what may be the possible relation? So x square is equal to my or mx square is equal to y. So this is the parabolic relation. So on parabolic relation, this limit will be satisfied. So simultaneously, x will go to 0 and hence y will also go to 0. Okay. So what we have to do is, what we are finding limit z tends to 0, f of z minus f of 0 on z minus 0. Okay. So any one of these two we can use. Okay. And hence we put mx square is equal to y. Okay, so I am replacing y by mx square. That is, as y tends to 0, this implies x will go to 0. Okay, and hence we get. So what you are able to get is limit z tends to 0, f of z minus f of 0 on z minus 0 is equal to limit, we are going with x now. So x tends to 0, x square, mx square, and we have x raised to 4, mx square square. See, what we are doing, we are replacing y is equal to mx square. So we have to be careful what we are replacing. Okay. And now this is equal to limit x tends to 0, x raised to 4m, x raised to 4 plus x raised to 4m square. So I can write this as limit x tends to 0, x raised to 4 into m upon x raised to 4 1 plus m square. We can cancel out this x raised to 4 and we have limit x tends to 0, m upon 1 plus m square. So what we got here, limit z tends to 0, f of z minus f at 0 upon z minus 0 is equal to m upon 1 plus m square. Now we can see, okay, so we can write, since the above limit depends on the value of m, that is, it depends on r, okay, and hence it does not exist. So we can say f dash of z at z is equal to 0 does not exist. So if the derivative does not exist, then we can say the function is not analytic, and hence f of z is not analytic at z. So this way, we are able to show that though the CR equations are satisfied at particular point, but the function is not analytic at that. Okay, that's why we have to be careful. Okay, that if the function satisfies CR equation, that does not mean it will be analytic. Okay. So, do you have any doubt in this example? Okay. So, if you have any doubt, please you can ask. Is there any doubt? If you don't have any doubt, then we'll try some more example based on CR equations now. Okay. So, let's have another examples. Okay. Yeah, is my voice clear? Everybody is able to hear me?
Yes, sir.
Okay. Okay. Let us see the another example. So this is example based on the CR equation. So we can have find the values of constants A, B, C, and D if f of z is equal to x square plus 2a x y plus ey square plus I cx square plus 2 dxy plus y square is analytic. Okay. So you can see in the previous case that was given the function we have to show whether it is analytic or not. And now here it is given that the function is analytic. And then we have to find out the value of this constant a, b. So we have to find the value of this constant a, b, c, and d. Okay, and here the given information is that the function is analytic. Okay, so what it means the function is analytic. So this gives you the idea that the function satisfies CR equation. Okay, and hence we have to use the CR equations to show that or to find this constants a and b, a, b, and c and d. So let us try this constant. Okay. So you can have, so we go with the solution. What we'll have here, like f of z is equal to, so it is x square plus 2axy plus by square plus I cx square plus 2dxy plus y square be an analytic function. Okay, so these are going to be an analytic function. Okay, so if these are analytic, this is an analytic function, then we have, what will be having, u is equal to ax square plus 2, we have, this is x square plus 2axy plus by square, and v is equal to cx square plus 2dxy plus y square. Okay, so this function is analytic. That means definitely it is going to satisfy CR equation. Okay, so we consider the first order derivative, and then we have the CR equation. So consider w by wx. So what you're having here, 2x plus 2ay. Then w by wy. So it is 2ax and plus 2by. Okay, so the derivative of this term. Okay, and next what we have to consider the derivative of v. So and w by wx. So it is going to be 2cx plus 2dy. And what will be w by wy? So it is going to be 2dx and plus 2y. Okay. So what we can say is, since f of z is an analytic function, hence u and v satisfy CR equations. So we have, what are the CR equations we have? So we are having w by wx is equal to w by wy, and w by wy is equal to minus w by wx. Okay, so this is what we have. Now let us use this condition, first condition. Okay, so now we have w by x is equal to w by y, and that is what we can have is this is 2x plus 2ay is equal to w by y, so it is going to be 2dx plus 2y. Okay. So what we can do is these are the two polynomials are equal. So when we say two polynomials are equal, if their corresponding coefficients are equal, so we can write comparing the coefficients of x and y on both sides, we get. So what you are able to get is 2 is equal to 2b and 2a is equal to 2. So from here I can get that b is equal to 1, and from here I can get that a is equal to 1. So this way we got the value of b and a. So here we got the value of b and a. Now we have to consider the another equation, and then we have to find what is the value of b and c. Okay, so we can write we have w by y equal to minus w by x. Okay, so let us have these values. So what is the value of w by y? 2ax plus 2by. Okay, and minus this term. Okay, so I can write here. So it is going to be 2ax plus 2by equal to minus time. Okay, so see this. What I'll get is 2cx plus 2dy. Okay, so it is going to be 2cx plus 2by. Okay, and hence what is the term I'll be having? 2ax plus 2by is equal to minus 2cx minus 2b. And hence again we can say comparing the coefficients of x and y on both sides, we get. Okay, so what we are able to get is 2a is equal to minus 2c and 2b is equal to minus 2b. So as we know, the value of a is going to be 1. Okay, and the value of d is also 1. So I can write here 2 is equal to minus 2c and 2b is equal to minus 2. Why am I able to write down that? Since d is equal to 1 and a is equal to 1. So we put the value of a and b here, and then we get this equation. So from this equation, I can write c is equal to 1, and from this equation, we can write b is equal to minus 1. So you got c is equal to minus 1 and b is equal to minus 1. Okay, so this way we are able to get the value of the constants a, b, c, and d when we know that the function is going to be analytic. We write here, okay, so if f of z is an analytic function, okay, then what we get here, a is equal to 1, b is equal to minus 1, c is equal to minus 1, and d is equal to. So this is what the values of a, b, c, and d we are able to get here. So we get values Okay. So, do you have any doubt in this example? Okay. So you are able to get all this thing. Great. Very good. Okay. So if you have any doubt, please you can ask. Okay. So we'll try one more example based on this. So let's have another example. Go with the example. Find the value of find the values of A, B, C, D, and E if f of z is equal to A x raised to 4 plus B x square y square plus C y raised to 4 minus here we are going plus D x square minus 2y square plus I 4x cubed y minus E x y cubed and plus 4xy is analytic. Is an analytic. Okay. So this is given that it is an analytic function, and then we have to find out the value of this A, B, C, D, and E. Okay. So we have laid f of z is equal to A x raised to 4 plus B x square y square plus C y raised to 4 plus D x square minus 2y square plus I 4x cube y minus exy cube plus 4xy is the analytic function. An analytic function. Okay, so this is an analytic function, and hence we have. Okay, so what is the term I'll be having? So I'll be having u is equal to a x raised to 4 b x square y square plus c y raised to 4 plus dx square minus 2y square, and I'll be having b is equal to 4x cube y minus exy cube plus 4xy. Okay, so that's what we have. Now let us try to solve this. So what we know is, since f of z is an analytic function, hence u and v satisfy your equations. So this functions u and v has to satisfy the CR equations. So let us find out the first order derivative, and then we'll use the CR equations. So we have w by wx is equal to 4ax cubed plus 2bxy square and plus 2dx. So the derivative of this term is going to be 0 because we don't have any x term here. The derivative of this term is going to be 0 because we don't have any x here. Okay, and then we have w by w y. So we'll be having 2bx square y plus 4c y cube and minus 4y. And now we have to consider the derivative of this term. So we'll be having w by w x. Okay, so this is 12x square y minus ey cube plus 4y, and you will be having w by w y is equal to, so it is 4x cube minus 6, so here we get minus 3e x y square, and you will be having plus 4y. So 4x here we have, because we are finding the derivative with respect to y. So we have 4x cube minus ex y square plus 4x. Now let us use the CR equations, and hence the CR equations are what are the CR equations? W by Wx is equal to Wb by Wy, and W by Wy is equal to minus Wb by Wx. Okay, so let us use this, that this term equal to this term. So we can have now consider W by Wx is equal to Wb by Wy, and hence what we'll get here. So it is 4ax cube plus 2bx y square plus 2dx is equal to this term. So we'll be having 4x cube minus 3exy square plus 4x. Okay, so what we can do is comparing coefficient on both sides. We can have, okay, so comparing the coefficients on coefficients of what we'll be having x cube, xy square and x on both sides. Okay. Okay. So what we are able to get here, see this. The coefficient of x cube is 4a. On the other side, it is going to be 4. Then this is 2b, and here we have minus 3. And then here we'll be having this 2b is equal to v of 4. So from here, I can get a is equal to 1. Okay, so we got the first coefficient. Here we have b is unknown, e is unknown. So let this equation as it is. And then for this, what we can say is 2 we can cancel, and we can write hence d is equal to 2. So we got here that a is equal to 1 and d is equal to 2. Now we have to think what happens if I consider this equation. Okay, so now we have w by wy is equal to minus wb by wx. So let us see what is w by wy is. Okay, so we got this term here, 2bx square y plus 4cy cube minus 4y. Okay, here I'll write 2bx square y plus 4cy. So 2b x square y plus 4c minus 4y. So see the coefficients here. So it is going to be 2bx square y, 4c y cube. So 2bx square y, 4c y cube minus 4y. And this is equal to minus. Okay. So we have here, this is 12x square y minus ey cube. So it is 12x square y minus ey cube plus 4y. Okay. So please be careful while writing the term. So it is 2bx square y, 4cy cube minus 4y. And then this is 12x square y minus ey cube plus it is going to be 4y. Okay. So that's what we have. Now simplify this. Okay. So when you simplify, we'll get 2b x square y plus 4c y cube minus 4y is equal to minus 2 12x square y. Here we have minus minus plus e y cube and minus 4y. So we can write 2bx square y plus 4c y cube is equal to minus 12x square y plus ey cube. Okay, and here we can compare the coefficient on both sides. Okay, so we can write comparing the coefficients of x square y and y cube on both sides, we get. So what we have here, see, this is 2b is equal to minus 1 and we get 4c is equal to e. Okay, so what we know here, b is going to be minus 6. Okay, so from this equation we are able to get b is equal to minus 6. Okay, now as we know, what we know, 2b is equal to minus 3e. Okay, so we have 2b is equal to minus 3e. Okay, so that equation we have to use, and hence what we'll get here. So I'll have okay. What is the term I'll have here? Okay, so I'll have here this term is equal to 2 into this is minus 6 is equal to minus 3. So we have minus 12 is equal to minus 3 and hence e is equal to 4. So we get here e is equal to 4. Now what we have is, so consider, now consider this equation. So we have 4 into, so this is 4c is equal to 4. We have calculated the value of e and hence we get here c is equal to 1. So we got the value of a. Okay, so here we get the value of a. Here we get the value of b and c. Here we got the value of d, and now we got the value of e also. So we got all the required values, and hence we can say if of z is analytic function, then what we can say is A is equal to, okay. So what is the value of A we have calculated? C. A is going to be 1. Okay. So we got A is equal to 1, B is equal to minus 6, C is equal to 1, E is equal to, what is the value of D we have calculated? So here D is 2. Hence we can write D is equal to 2 and E is equal to. So this way we are able to calculate the values of this constant A, B, C, E, and K. So this is how we calculate value when we know the function is going to be analytic. So in these two examples, we have seen that the function is given to be analytic. So here function is given to be analytic, and then if it is going to be analytic, we are able to use, okay, CR equation. So function is analytic, that means it satisfies CR equation, and the first order derivatives are continuous. So we can say the function f of z is analytic if and only if it satisfies the CR equation and the first order partial derivatives are continuous. So we can make it as if and only if now. So if the function is analytic, then this way is going to happen that the u and v will satisfy CR equation and the first order derivatives will be continuous. Okay. Now in this example, we have seen that if the function is analytic, so here what we have, this function f of z is analytic, and you can see the first order derivative. The first order derivatives are all polynomials. Okay, so these are all polynomials, and we know these polynomials are always continuous. So they satisfy CR equation as well as they are continuous. And using this information, we are able to find the values of the constant which are not given to us. So we are able to find using this. So do you have any doubt in these two examples, whatever we have solved today? So is there any doubt? Okay, that's great. So you don't have any doubt. Very good. Okay, so I hope you understood all these examples properly. Okay.